Hey everyone, Miss Hood here. Today I'm going to talk to you about free body diagrams. A free body diagram is a diagram that shows both the magnitude and direction of all of the forces acting on an object. Let's go through this example. Here I have a car moving to the right along the road. To start my free body diagram, I first locate my center of mass. This is just the center of the object we're looking at, and that's what this yellow dot here represents. On the left-hand side, I have a list of all of the possible forces I could have on my object. When I do my free body diagrams, I treat this as sort of a checklist to see what I need to include. So let's go through them one by one. Pay attention to the questions I'm asking myself as I go through them. First up, I have air resistance. And I ask myself, is my object moving through the air and not on a surface? Since I just have my car moving along the road, that means I don't have air resistance here. Next up, I have applied force. And I ask myself, is there another object applying a force to my car? Again, since the car is by itself, I don't have applied force here. Next up, I have friction. And I ask myself, is our object moving along a surface? Since I have my car moving along the road, that means I have to have friction here. So I take my arrow and I line it up to my center of mass. It's important to remember that friction always acts opposite the direction of motion. So since my car is moving to the right, I need to make my arrow pointing to the left. And of course, I gotta take my label and make sure I label it as friction. Next up, I have gravity. Now keep in mind, as long as we're on the earth and not in space, you will always have a force of gravity on your object. So I take my arrow and I line it up with my center of mass. It's important to remember that gravity will always point directly down, no matter what our object is doing. Next up, I have normal force. And I ask myself, is our object on a surface? As long as the object is on a surface, we will always have normal force. Keep in mind that normal force is always perpendicular to the surface. So in this case, my normal force will be pointing directly upwards. Keep in mind that might not always be the case, and it really just depends the angle of your surface. Last but not least, I have tension. And here I ask myself, is there a string, a cable, or a chain pulling my object? Again, since the car is just by itself, I don't have tension force here. That's it. This is our free body diagram for a car moving to the right along the road. Keep in mind, we can also have you just draw the forces starting from a basic center of mass. So for this object, this is how the free body diagram would look without the picture. All right, let's go through another example. Here I have a boy pushing a box to the left along the floor. This time, try and label the forces on your own using the questions I asked myself. Go ahead and pause the video here. Well, did you get it? Take a look. First up, I have gravity. Remember that this force is always present and will always point directly down. Next up, I have normal force. As long as my object is on a surface, normal force will always be perpendicular to that surface. Since the boy is pushing the box, there is an applied force in the direction of movement. And last but not least, because the object is moving along the surface, I have friction facing the opposite direction of motion. That's it. That's how you draw free body diagrams. Now go ahead and try some on your own.